In this lecture, I'm going to be talking about climate change, global change in the Earth system. So some of the things that we're going to be talking about today are the Earth is a dynamic planet. And some of these changes that we see are unidirectional versus some are cyclical. I'm going to explain what those mean and how they can happen at different rates. There are elements or compounds that flow among various reservoirs, and we'll be looking at how the Earth's climate changes and the role of greenhouse gases that serve in regulating climate. We have evidence for contemporary climate and sea level change, and there's many ways in which the human changes the Earth, and the Earth may still be undergoing lots of changes in the future. And we're going to be looking at ways that you can also contribute towards, reducing your footprint and what global climate change means for Californians. So first, I'm just going to get this out there. Is climate change real? And I'm pretty sure the answer is yes. There are many studies and science that shows that the Earth is changing as a result of humans. And I don't want to make anything political, but I think that there's a lot of science and evidence that supports climate change. And we need to do our part to think about our role as a consumer when we talk about our climate and how we can contribute to the future of our race and of our resources. So like I said, there's different changes that the Earth undergoes. We have cyclical and we have unidirectional. So some things that are unidirectional are like the evolution of the solid Earth. We start from its formation, and then it creates we have oceans and crust and plate tectonics, and then the plates separate, and we have creation of rivers and mountains and all these things. That's sort of a unidirectional change. We're not really going to go back to not having oceans or not having plate tectonics. That's an example of a unidirectional, one-directional change. The evolution of the atmosphere and oceans, this is another example of a unidirectional change. This is where the atmosphere has changed over time. First, we start with gases in the early atmosphere, mostly carbon dioxide. And as the Earth cooled and the oceans were formed, the CO2 dissolved and our atmosphere became oxygen-rich. That's one directional change. The evolution of life is another example. We have concluded that there's pulses of evolution, and of course, our stratigraphic record and our study of the Earth has shown that there's mass extinction events. We talk about this in the fossils lecture about how we have global events like volcanic eruptions or asteroid impacts and things like this that support the evolution of life, which is a unidirectional change. Now, contrary to that is a cyclical change. This is when the Earth goes under changes on a much larger timescale. Think about geological time. These things are like, cyclical sea level change, or sometimes we have biochemical cycles and hydrological and carbon cycles as well. So when we think about sea level change is indeed a cycle. We've undergone huge sea level rise and fall, as much as 300 meters during the Phanerozoic and Precambrian age. The global sedimentary cycle chart may largely reflect cycles of the eustatic sea level change that we see here on the right-hand side. And eustatic means a worldwide view. So think about sea level in a global sense, and some of the things that can contribute to global or eustatic sea level change are, glacier melting, glacier retreat, the creation of a mid-ocean ridge, things like this. Those are global events that have changed the sea level. So if we look at, these are millions of years ago in time here. So we have rise and fall from not just glacial periods, but also some of these other large plate tectonic type events. And we see that sometimes these sea level changes, rise and fall, can be cyclical. So we've had some very high sea level in our past, in our long distant geologic past. And so when we think about sea level today, is that reasonable? Should we be terrified? And we're going to talk a little bit about that in just a second. Some of the other cyclical challenges or cyclical changes are biogeochemical, and this involves the passage of chemicals among non-living and living reservoirs in our system. So a non-living reservoir would be like the atmosphere or rocks and soils, and the sea, whereas living reservoirs include plants, animals, and microbes. The cycle may take hours, and other times it may take millions of years. And so when we think about other components of a biogeochemical cycle, we think about the hydrologic cycle, which is the movement of water from reservoir to reservoir, like water that's been stored in oceans that moves into a glacier, or if the glacier melts and returns to a river or something. And we also have the carbon cycle, which is where we have CO2 gas is released into the atmosphere. The gas is released during like a volcanic eruption, for example, and or we might have global decay of organisms, and therefore it produces these carbon byproducts that can be turned into fossil fuels. So all these other little cycles exist, and they are seen cyclical because of their large global events. So when we think about global warming, what does that actually mean? Well, in short, the Earth is undergoing changes right now. And should we be worried about global warming? Well, I think that there is an increase in carbon dioxide in the atmosphere as a result of the greenhouse effect. And therefore, there's a correlation with an increase in temperature. So currently, the Earth is going through a warming period, and part of that is cyclical. But I think part of it is also contribution of humans and the impact of our consumption and our existence on the Earth. So some of the consequences of when the Earth warms up includes the ice retreat and snow line. We have melting of permafrost. We have a shift in those climate belts. If you remember way back to the first lecture about plate tectonics, we talk about climate belts and how important that is for certain organisms to live, or certain plants and animals that rely on their food chain within that climate belt. So if we have significant changes, that can impact a lot of critters and things like that. We have typically stronger storms. And of course, something that we've dealt with here in California is an increase in wildfires. So like I said, a shift in climate belts. As climate warms, the temperature and desert regions would occur at higher latitudes. So regions that may be, home to a lot of agriculture, as the temperature increases, may become too dry, or we may not have as much groundwater available to make it, farmable. The change in climate will also affect the amount of distribution of precipitation that falls. And I think that part of Central Valley, California is seeing some of this change, that it's becoming more arid. And so there aren't as many farms that are producing right now. Ice retreat and snowline rise. So as global warming increases, the volume of water held into that glacial reservoir causes the sea ice to decrease. So it's being exposed, the surface area of that, and so we see that we have ice retreat, and of course the snow line rises. So sometimes we see the snow line, or you might hear a forecast if you are a skier, that there's so much snowfall in Mammoth, but the snow line goes until 5,000 feet elevation, or maybe it's 6,000 feet elevation. Well, if we have more global warming impact, the snow line would be higher and higher. And of course, we'd have less snowpack, and therefore less runoff. So there's a lot of impact for when we don't have as much snowfall, and therefore less water into our reservoirs. We talk about permafrost in the weathering section of this class. And if you remember, permafrost is usually in the polar type climates, like we see in Antarctica and Canada, and places that have significant freeze thaw due to temperature. And so when we have warming climates, those tend to thaw more during summer. And as it melts, it causes that organic material to decompose and release methane. So you think that that's not a huge problem, but if you think about it on a global scale, release of methane into the atmosphere, it certainly contributes to the problem. And so, like I said, we have sea level rise. That's one of the topics that are causing a lot of concern right now. So as water expands when heated, it causes global or that eustatic sea level to rise. And of course, glacial melting can cause sea level rise as well. And there's been evidence of a lot of glacier melting within the last century or so. And here's an image I snagged from Zillow. So if you can probably grab one here from coastal California, but I thought this one was interesting to show which homes are at risk due to coastal flooding by 2100. So if you're in the market of purchasing a home in Florida, your retirement home, maybe you'd want to stay away from Dade County or Broward County because those are very coastal on the Atlantic side, and maybe those homes there would be at risk to sea level rise. Of course, here in California, being coastal, we are at risk of sea level rise as well. Another one is stronger storms. So we've seen this. We've seen some really strange activity, especially this last summer, where we had the first, it wasn't quite a hurricane, but it was close to becoming a hurricane since 1932 here in California. So that's some unusual weather. The Gulf also experienced a double hurricane where there was like two hurricanes that merged. How crazy is that? So, of course, as we have changes in temperature, ocean temperature means that there's those other, tropical depression storms. And of course, these can create stronger hurricanes or multiple hurricanes or hurricanes where there aren't normally hurricanes. And areas without deserts may receive increased precipitation and therefore experience flooding. So it can go on the other side too, of where we have lots of hurricanes, but we also experience rainfall in places that it normally doesn't. So these abnormal storms are happening more often. And of course, increase in wildfires. As warmer temperatures increase, it impacts the moisture content in the plants and can increase the frequency of wildfires. Here in Ventura County, we're very susceptible to those Santa Ana winds, which are winds that are being blown in from the central part of the state that are very warm. The winds are very hot in temperature, and so that those high gust winds, as well as the temperature, makes it pretty scary for some of those wildfires here in California. So what do we do that impacts the earth? And I think that these are some of the questions that you might have. And what I'm going to do is I'm going to show you this website that shows some of the global impacts to California. So I found this website here that shows a little bit about, well, what does it mean to be a Californian during, global warming and what the data might show. And so we can see here that we do have an increased temperature, certainly within the last few years. And of course, this is projected out based on data within the last few decades of what our temperatures are like. And of course, temperature is cyclical, but this is a pretty bleak looking outlook of what temperatures will be like by 2090. So you can look at how they've chosen this data for different regions of California. You can also look at sea level impact. So if we look at the California coast, this is more focused around Long Beach, but you can see that certainly parts of Long Beach and coastal areas would be impacted by increase in sea level rise. So if I select a sea level rise of 1 meter, you can see how parts of, near Huntington Beach would be invaded with water. You can see how grim this might be. Even parts of inland California could be impacted that are near the San Joaquin River or deltas and things like that. And of course, we can look at what those energy goals are. How do we impact and what those changes would be like if we change our habits? So I recommend that you go and check out this website and peruse it a little bit more to learn more. So some of the things that we do that could be impacting all of these things include the modification of landscapes. we had a lecture about mining, and not only consumption of goods, but also, we're bulldozing hillsides sometimes. We also control the coastline by building levees, and we talk about that in our previous lectures as well. We also use stuff for our ecosystem with agriculture and deforestation and urbanization. And because of that, we pollute. We have water contamination, and we use radioactive materials, and of course, air quality is an issue. So some of the things that you can do, if you're wondering how you can help make an impact. Now, these are just some suggestions, and I recommend that you do some research to figure out what might your impact be and how you can change that. So if you own a home or if you rent or something, you could always just change some of the light sources, in your home, or make sure that you turn off lights. And that seems a little bit trivial, but if you think about it on a large scale, if we all can consume energy and optimize, then everyone contributes to the greater good here. So we can try and use renewable energy sources for your home or your vehicle. You can weatherize your home if you have the ability to, by putting in new windows or weather stripping and things like that. Use energy efficient electronics and appliances. You can reduce your water waste. The previous lecture about groundwater, you did an exercise where you had to input what your water consumption is. So maybe doing things like, having higher efficiency shower heads or toilets, that can also reduce your water consumption. One of the things that from that quiz showed me was that having a meat diet can actually have a huge impact. And that's true with water as well as methane emissions and things like that. So you can optimize your diet by not only consuming what you purchase, but consider reduction of certain products. And of course, reducing our plastic and our dependency on oil, even though it is a large economic business for a lot of the country. So those are some things that you can do. And I hope that this is a brief overview of climate and climate change. This is an ever-changing field and a moving target as to figuring out what the best course of action is going forward. But some of the things that we talked about in this lecture include that the Earth is a dynamic planet, it's ever-changing, and the changes that we see can be unidirectional and some are cyclical. We talk about greenhouse gases and how they change. And we looked at some sea level impact of what that looks like for glacier melting and things like that. And of course, we have an impact on the Earth, and there's things that we can do to make a difference to change the future. That's it for this lecture. Bye, guys.